For this activity 3, we are going to talk about the AND gate, and we are here to demonstrate and simulate the basic function of the AND gate and its application. The AND integrated circuit is another logic gate with a different function. This gate simply outputs a high signal, or 1, only when all of its inputs are high, or 1. The symbol for the gate comprises of a semicircle on top of a rectangle. The input side is from the rectangle side, and the output side is out the semicircle. The truth table for the AND gate is very easy compared to the other gates. When both the input is 1, the output is 1. Otherwise, the output is 0. It basically only accepts as 1 for its output to output 1. Next is the 74 LSO-8 integrated circuit with its 14 terminals. One terminal is for the power input, at the opposite end is the ground terminal. The remaining 12 terminals make up the 4 inverters, having 3 terminals each for the 2 inputs and 1 output. Shown here is the diagram of this integrated circuit. Our goal for this activity is to figure out what is the outcome for this 8 LEDs and LSO-8 configuration. Analytically, we can try to figure out the output of each LED with its corresponding inputs. For L1, L2, L3, and L4, their corresponding switches just must be on or 1 for it to be on. At L5, both inputs from D0 and D1 must be on or 1 for gate A to output 1, turning L5 on. For L6, gate C only takes input from the same switch D2. So if it outputs 1, the gate takes both inputs as 1 and outputs 1 to turn on L6. If D2 is off, L6 is also off. For L7, gate B takes both input from gates A output. This would signify that L5 and L7 will have the same output always. If L5 is on, L7 will also be on. Otherwise, they are both off. Lastly is L8. It takes input from gate D, which takes input from gate C and switch D3. But since gate C is just inputs from D2, we can say that gate D takes input from D2 and D3 and turns on L8 when both switches are on. Here is the truth table of the significant changes of its respective inputs combination. So let's start! The materials needed for this activity are breadboard, jumper wires, 4 push buttons, a power supply, 8 pieces of 3.9 kilo ohms resistors, 8 pieces of red LEDs, and most importantly, the 74 LSO-8 integrated circuit. Before we start with the hands-on proper, we can simulate the configuration using Tinkercad for easy rebuilding of the hands-on circuit. After multiple troubleshooting, we now have the working circuit which coincides with our analytical solution. Before we begin, let's check if the components are now working. Now, we can start.
Saw you in the red dress. I can't seem to understand how you got all that finesse. Still been running in circles inside my head.
As you can see, the output of our hands-on circuit coincides with our Tinkercad simulation and also coincides with our analytical analysis from before. In this activity, we demonstrated the functionality of the AND gate using the 74 LSO-8 integrated circuit. The gate only produced a high output, or 1, when both inputs were high, or when both outputs are 1, consistent with its truth table. AND gates are integral to digital logic, forming the foundation for more complex systems like adders and control circuits. Further experiments could include combining AND gates with other logic gates to explore more advanced logic operations. I hope you learned something. Thank you for watching.